Hi, in this video we will study another set of properties of definite integrals and in which we will see how definite integral and inequalities work together. Well, again, we are assuming that we have two functions which are integrable on an interval a, b. First thing to see here is that, well, if a function is positive, so if f of x is bigger than or equal to 0 for all x in the interval ab, then integral of f of x from a to b is going to be a positive number. So if all the values are positive, you will see that the integral is also positive. You can also go a little bit further and you see that if a function is bigger than or equal to another function for all x's in the interval ab, then the integral of the bigger function is going to be bigger than integral of the smaller function. In other words, the function, the integral, definite integral is increasing functional in some way. And while in particular, if we know that a function f of x is between two numbers for all x in the interval ab, so if we know that function is between, let's say, absolute mean here, absolute max, capital M, yes, then integral of that function from a to b can be approximated by integrals of these constants. You see, this is going to be integral of m a to b dx, and this is going to be integral of lowercase m dx a to b. Well, we know that if you have a constant, you look at the area there, the region is going to be rectangle, and well, either positive, negative m, doesn't matter, it will be the area of that, or the width times m, and this guy is going to be m b minus a. And while seeing these properties is not difficult, I will just go ahead and do one graph for the second one. You see, if I have two functions, let's say both of them are positive in this case, this is f, and we are supposed to have g less than f. Okay, this is f. F is above g. Then from the on the interval a to b, the integral of g dx is going to be the region of the area of the region, this piece here. And it is obvious that this is less than the area of the bigger function, and that's how you show that the second property, which is, by the way, equivalent to the first property, is true. Okay, let's see some examples here. The last property that we saw there can be useful to estimate some of the functions. Meaning what? Meaning that I don't know how to compute this integral now, but I know that sine squared x is between well, sine x itself is between 1 and -1 on the interval negative pi over 2 and 3 pi over 2. If you square that, this is going to be a number between 1 and 0. Square is always positive, yes? Now, from using the last property that we saw here, integral negative pi over 2, 3 pi over 2, which I don't know how to compute yet, is going to be less than 1 times 3 pi over 2 minus negative pi over 2. And it's going to be greater than 0 times b minus a, which is this. So in other words, the integral of sine squared from negative pi over 2 to pi is going to be between what? 4 pi over 4, which is 2 pi and 0. It will be a number over there. So I don't know what is the exact number, but I can definitely say that it's not going to be a number like 8. It's not going to. It is between 2 pi, which is 6 point something, and 0. And it's not a negative number. Definitely I can say that. Okay. How about this one? Well, we have e to the power x squared. The best approximation you can get here is using absolute max and mean on the interval. So on the interval 1 and 2, the absolute max is e to the power 4, and absolute mean is e to the power 1. So in other words, e to the power x squared, the function is between 2 and 1. Then we can use the property, the integral of that, not 2 and 1, e to the power 1 and e to the power 4 on the interval 1, 2. Then e to the power x squared dx is going to be between e to the power 4, 2 minus 1, and e to the power 1, 2 minus 1. From this, we know that the value of e to the power x squared dx from 1 to 2 is a number between e to the power 4 and e. This one, we can actually compute the value using the Riemann sum, but again, I can see that x2 on the interval -1, 3 has absolute max equal to 9, and absolute mean, you can find this, yes, you know how to do this, absolute mean 0. So x squared is between 9 and 0 on the interval -1, 3. Then the integral of x squared from -1 to 3 dx is going to be between 9 times 3 minus -1 and bigger than 0 times 3 minus -1. This means that, well, we can say at least something about this. This integral is going to be a number less than 36 and bigger than 0. So those properties can be used to estimate the value of